1.3.2. Estimating to the nearest tens by rounding off. Observe this. We have a row with many boxes, each with a 3-digit number. The numbers start from 259 and go all the way to 271. We have some colored flags on some of the numbers. A. Find which flags are closer to 260. B. Find the flags which are closer to 270. Locate the numbers 10, 17 and 20 on your ruler. Is 17 nearer to 10 or 20? The gap between 17 and 20 is smaller when compared to the gap between 17 and 10. Below this we have the picture of a ruler with divisions from 1 to 30 showing the centimeters of the ruler. The number 17 has a flag on it in the picture. Also, the numbers 10 and 20 have been highlighted. So, we round off 17 as 20, correct to the nearest tens. Now, consider 12, which also lies between 10 and 20. However, 12 is closer to 10 than to 20. So, we round off 12 to 10, correct to the nearest tens. How would you round off 76 to the nearest tens? Is it not 80? We see that the numbers 1, 2, 3 and 4 are nearer to 0 than to 10. So we round off 1, 2, 3 and 4 as 0. Numbers 6, 7, 8, 9 are nearer to 10. So we round them off as 10. Number 5 is equidistant from both 0 and 10. It is a common practice to round it off as 10. Page 19. Try these. Round these numbers to the nearest tens. "28, 32, 52, 41, 39, 48, 64, 59, 99, 215, 1453, 2936. 1.3.3 Estimating to the nearest hundreds by rounding off. Is 410 nearer to 400 or to 500? "410 is closer to 400. So it is rounded off to 400, correct to the nearest hundred. "889 lies between 800 and 900. It is nearer to 900, so it is rounded off as 900, correct to nearest hundred. Numbers 1 to 49 are closer to 0 than to 100, and so are rounded off to 0. Numbers 51 to 99 are closer to 100 than to 0, and so are rounded off to 100. Number 50 is equidistant from 0 and 100 both. It is a common practice to round it off as 100. Check if the following rounding off is correct or not. "841 as 800. 9,537 as 9,500. 2,546 as 2,500. 286 as 200. 168 as 200. 149 as 100. 49,730 as 49,700. 5,750 as 5,800. 9,870 as 9,800. Correct those which are wrong. (1.3.4) Estimating to the nearest thousands by rounding off. We know that numbers 1 to 499 are nearer to 0 than to 1000. So these numbers are rounded off as 0. The numbers 501 to 999 are nearer to 1000 than 0, so they are rounded off as 1000. Number 500 is also rounded off as 1000. Check if the following rounding off is correct or not. $2,573 as 3,000. 53,552 as 53,000. 6,404 as 6,000. 65,437 as 65,000. 7,805 as 7,000. 3,499 as 4,000. Correct those which are wrong. Page 20. Try these. Round off the given numbers to the nearest tens, hundreds, and thousands. We have 3 columns. Column 1 heading is Given Number. Column 2 heading is Approximate to Nearest. Column 3 heading is Rounded Form. Given number 75847. Approximate to nearest tens. Rounded form dash. Given number 75847. Approximate to nearest hundreds. Rounded form dash. Given number 75847. Approximate to nearest thousands. Rounded form dash. Given number 75847. Approximate to nearest 10,000s. Rounded form dash. Write all the 4 answers in the blank spaces provided. 1.3.5 Estimating outcomes of number situations. How do we add numbers? We add numbers by following the algorithm, that is, the given method, systematically. We write the numbers taking care that the digits in the same place, that is, ones, tens, hundreds, etc., are in the same column. For example, 3946 plus 6579 plus 2050 is written as we have the numbers written in a tabular form with the headings of the columns as thousands, hundreds, tens and zeros. The numbers are added in their particular places. 3946 plus 6579 plus 2050. The answer is dash. We add the column of ones and, if necessary, carry forward the appropriate number to the tens place, as would be in this case. We then add the tens column, and this goes on. Complete the rest of the sum yourself. This procedure takes time. There are many situations where we need to find answers more quickly. For example, when you go to a fair or the market, you find a variety of attractive things which you want to buy. You need to quickly decide what you can buy. So you need to estimate the amount you need. It is the sum of the prices of things you want to buy. A trader is to receive money from two sources. The money he is to receive is 13,569 rupees from one source and 26,785 rupees from another. He has to pay 37,000 rupees to someone else by the evening. He rounds off the numbers to their nearest thousands and quickly works out the rough answer. He is happy that he has enough money. Do you think he would have enough money? Can you tell without doing the exact addition or subtraction? Sheila and Mohan have to plan their monthly expenditure. They know their monthly expenses on transport, on school requirements, on groceries, on milk, and on clothes, and also on other regular expenses. Page 21. This month they have to go for visiting and buying gifts. They estimate the amount they would spend on all this and then add to see if what they have would be enough. Would they round off to thousands as the trader did? Think and discuss 5 more situations where we have to estimate sums or remainders. Did we use rounding off to the same place in all these? There are no rigid rules when you want to estimate the outcomes of numbers. The procedure depends on the degree of accuracy required and how quickly the estimate is needed. The most important thing is how sensible the guessed answer would be. (1.3.6) To estimate sum or difference. As we have seen above, we can round off a number to any place. The trader rounded off the amounts to the nearest thousands and was satisfied that he had enough. So when you estimate any sum or difference, you should have an idea of why you need to round off and therefore the place to which you would round off. Look at the following examples. Example 5. Estimate 5,290 plus 17,986. Solution. You find 17,986 greater than 5,290. Round off to thousands. (17,986) rounds off to 18,000. 5,290 rounds off to 5,000. Estimated sum is equal to 23,000. Does the method work? You may attempt to find the actual answer and verify if the estimate is reasonable. Example 6. Estimate 5,673 minus 436. Solution. To begin with, we round off to thousands. Why? 5,673 rounds off to 6,000. 436 rounds off to 0. So, estimated difference is equal to 6,000. This is not a reasonable estimate. Why is this not reasonable? To get a closer estimate, let us try rounding each number to hundreds. (5,673) rounds off to 5,700, minus 436 rounds off to minus 400. Estimated difference is equal to 5,300. This is a better and more meaningful estimate.